Carbanion chemistry part 6, that is the fate of Carbanion. For the other videos for Carbanion, the corresponding playlist link you will get in the description box, and also for the other intermediates carbocation, carbene playlist, for that also you will get in the description box. So let's start. Different fates of Carbanions, and that depends on its structure and also what type of other reagents are available in the reaction medium. So depending on that, there may be different types of fates for Carbanion. So the first fate is Carbanion can capture a proton. So in this case, obviously it is acting as if it is a base. So if there is any acidic proton, it can capture it and ultimately it will become a neutral molecule. The second fate that is possible, it can undergo displacement reaction. So it will attack another center where some good leaving group is present. So displacement reaction, that is substitution reaction, is possible. The third fate is Carbanion can undergo addition reaction. So if we have any CC double bond near to C double bond O, or if we have any C double bond O, it is also possible with CC double bond, then the pi bond will be broken when the Carbanion will attack this carbon. Okay, so that is another type of fate. Then Carbanion can undergo elimination reaction. So in this case, obviously beta hydrogen must be present with respect to the leaving group, the corresponding position of this hydrogen, that should be beta, and there should be some acidic in nature in this beta hydrogen. So in this case also it is behaving as if it is a base, and it is mostly observed in E1CP type of mechanism. And the last one is it can undergo rearrangement. Now when it is undergoing rearrangement, it is not producing any stable neutral molecule. Obviously it is producing a new Carbanion. And it is also true that it is not so common that we observe in case of carbocation rearrangements, but still it is possible. So one by one we will discuss all these fates in detail. Carbanion can capture a proton. So in this case it will behave as if it is base. So here we have taken this general Carbanion structure, which is R3C minus. Here we have this acidic hydrogen. It is capturing this proton and we are getting, that is the fate of this Carbanion. Now it is converted to R3CH. So this new CH bond is formed. Now actual example, if we see, we know Grignard reagent, there is Carbanion type of nature. So this carbon metal bond, this will have this carbon basically. So if I am writing it like this, as if it is the bond is fully broken, then it will be like this. Though there is no free carbocation, but this bond, this carbon metal bond, because of polarity, it will behave as if it is Carbanion. So in this case we have this acidic hydrogen present in red color. So this Carbanion center, it will attack this hydrogen and ultimately there will be formation of carbon hydrogen bond that you have seen in this general example. And this MgBr part, the positive part, now it is attached to this CO2 minus. Another example, now this is also Grignard reagent. Here we have this carbon metal bond. So this will be the Carbanion center. If you imagine this bond as if it is broken, and it will take deuterium. Now instead of taking hydrogen, we have D2O here. So this D, it is also behaving as if it is that is acidic hydrogen type of behavior, and there will be formation of carbon deuterium bond. And this MgBr part, now it is attached to DO minus, that is the rest of the part of D2O. The second fate, it can undergo displacement reaction. So in this case we have this another substrate where carbon leaving group, this type of bond is present, so that after attack of this Carbanion, this carbon Lg bond is broken and leaving group is removed. We are getting new CC bond. Now actual example, if we take, here we have this Carbanion. It is stable because it is the negative charge is present over CC triple bonded carbon. And here we have this carbon bromine bond, which is basically analog of this CLG bond. So this negative charge, it will attack here. CBr bond will be broken and we are getting this new carbon-carbon bond. Another example, here again we have taken Grignard reagent. Now this is only a part of the mechanism, not full mechanism. I am just showing that part of the mechanism where the Carbanion is attacking. So here this Carbanion which will be generated over this R group, it will attack here and one of these OET bond that will be removed. Okay, so OET is the leaving group here and we are getting this R carbon bond. The third fate attacks C double bond O or alpha beta unsaturated C double bond O. So in this case, that is the first example, it is attacking this carbonyl carbon and the pi bond is broken, negative charges over oxygen. Now again it is a partial mechanism, only one step is shown where the Carbanion is attacking. If there is any acidic proton available, this oxygen that is the O negative, it can capture that. That is the ultimate reaction, but we are just seeing that part of the mechanism where the Carbanion is involved. Here we have alpha beta unsaturated carbonyl group. So this is attacking here. This is 1,4 attack. The first one is direct attack. Now this double bond, it will be shifted, negative charge over oxygen, and then further mechanism possible. So the first example, that is attack to C double bond O. The second one is attack to this type of system, alpha beta unsaturated carbonyl carbon. Here we have only a part of mechanism which we observe in aldol addition mechanism. So in aldol addition, there is first generation of Carbanion, and this Carbanion now it is attacking at this carbonyl carbon, negative charge over oxygen. We are getting this new CC bond. Michael addition, another important reaction. Here also only a part of mechanism. So this is the negative charge Carbanion, it is attacking. This is the 1,4 addition. Now the double bond will be shifted, negative charge over oxygen. If it is taking a proton from H2O plus, now we have this type of enol system, and then after ketoenol tautomerism, final molecule is this one. So here you can see this CC double bond that we have initially before the reaction. Now this CC, there is no pi bond, and we have this group which is coming from Carbanion and another hydrogen that will be coming from other reagent in the reaction medium. Okay, so this is the third fate. Now the fourth one is Carbanion can undergo elimination reaction, now which is mostly observed in E1CP type of elimination mechanism. Here we have some examples. This is the general scheme shown. Negative charge over carbon, it is making CC double bond, and this CX bond is broken. Here we have this mechanism where negative charge, that is the Carbanion, it is stable because of this electron withdrawing group. Now this negative charge, if it is making this CC double bond, OCH3 group, that will be removed. So this is again a part of the mechanism. Here we have this Carbanion. Now this Carbanion, it is having this carbon that is fluorine, which is at ideal position, it can act as leaving group. So CC double bond is formed and CF bond is broken, AF is removed as leaving group. Then different types of mechanism that is also possible. Here this bromine, it is in ideal position so that the negative charge can attack this carbon and ultimately CBr bond will be removed. We are getting this type of 3-membered ring involving this sulfur. Now further heating if we do, then SO2 can be removed, there will be some bond formation. So this is again a part of mechanism where only the Carbanion is involved, so that we can see how it is taking part in elimination reaction. Okay, so you can also see say that it is a kind of substitution, but if we consider that is the final CC double bond, then it will be under elimination. Okay, whatever it is, this is also a type of that is a fate that we can expect from Carbanion. Then we have rearrangement. This is the last fate that we will discuss in today's video. Now it will obviously generate a new Carbanion. Here you can see negative charge is present in the left hand side carbon, but after rearrangement it is present here. Now this is a general scheme, but actual rearrangement, if we take example, very good example you can observe in Favorsky rearrangement, and here we will see how this rearrangement is occurring. Here this negative charge, that is the Carbanion, it will attack this carbon which is carrying this leaving group. Now after removal of this Cl, there is formation of this 3-membered ring. Now HO minus, which is present in the medium, it will attack here, and C double bond O, that is broken, negative charge over oxygen, and finally If this negative charge is again forming C double bond O, one of these CC bond will be broken. Both side it is symmetrical. So any of this CC bond, it will be broken, and finally there will be negative charge over this carbon. So this CC bond is broken, and from this part we will get COOH. So this is an example of rearrangement that is involving carbanion. So initially we have carbanion here, but final after the rearrangement we are getting different types of different type of carbanion. But one thing we have to remember, it is much less common that we observe in case of carbocation. That is very common, but for carbocation it is very common, but not for carbon. Okay, so that's all we have in this video. If you like it, please, if you find it helpful, please like, share and subscribe. I'll meet you in the next video. Thank you for your time.